In today's class, we're going to look at another example where we're asked to find the pressure at the bottom of a cylinder. The cylinder has two fluids and it's open to atmospheric pressure. So the first fluid here is given to be water, and the second fluid on top is oil with a specific weight of 0.9, and water has a specific weight of 1. The height of these two liquids, for the oil it's 2.4 meters, and for the water it is 1.5 meter. The surface is open to atmospheric pressure. That's a free surface. And the diameter of this cylinder is 3 meters. Diameter equals 3 meters. Now we're asked to find the pressure acting at the bottom. We previously stated that pressure does not change in a vertical plane, in a horizontal plane, in a horizontal plane. It only changes vertically. Okay, so we're asked to find the pressure in the bottom horizontal plane. Okay, in order to do that, well, we have to start from the top. We'll say that pressure at the bottom will equal to, we'll start from the top, we'll use zero gauge. The reason we're using zero gauge and not absolute pressure is because we're taking these pressures into account, the pressure of these two liquids, oil and water, and they're measured in gauge. Of course, we can change them to absolute, but we rather work with them in gauge. I rather work with them in gauge, so I'll start with 0. Okay, plus. Now we know that pressure is specific weight times height. Okay, plus 0.9 times the height of oil is 2.4 meters, plus sorry, that is the SG, not the specific weight. SG of water and SG of oil. Okay, now you need to, we know that SG equals the specific weight of the substance divided by the specific weight of water. Now since our substance is oil with an SG of 0.9, therefore it will equal 0.9 times 9.81 kilonewtons per meter cube. Okay, so now we can start solving. Move this down here. So pressure at the bottom equals to 0.9 times 9.81, that's the specific weight of oil, times the height, which is 2.4 meters, plus, and the reason we're adding is because pressure increases as we go down, therefore we're adding, whereas pressure decreases as we go up. Therefore, plus specific weight of water, which is 9.81 kilonewtons per meter cube, times the height, which is 1.5 meter. We'll end up with pressure at the bottom equal to 36 kilopascal. Again, this is gauge because we're measuring the pressure inside the cylinder. Okay, now Therefore, the force, if we were asked to find the force, we know that pressure equals force over area. Now, force equals pressure times area. The area we'll be using is the area that the pressure is being acted on, which is this right here, this horizontal plane, okay, which is the diameter, which is the cross-sectional area of this circle here. That will be, area will equal to pi d squared over 4. Okay? And the pressure we just found, therefore, the force will equal to 250 kilonewtons. That's if we're asked to find the force. Now, what if the same problem is given, but the geometry is different? So, for example, if we were given a cone, I want to get the specs right here. Okay, this diameter might be a little bit bigger than the other one, but it was meant to be 3 meters, the same as this one. I'm trying to keep it relative. And we'll assume that the heights are also similar. So this is 1.5 meter, and this here is 2.4 meter. And on the top is oil with an SG of 0.9, the same as the first example. And here we have water, it's SG of 1. Okay, and the top is open to the free surface, is a free surface. Now the question is, will the pressure at the bottom of the cone be similar to the pressure at the bottom of the cylinder, even though the parameters are the same? The only difference is the geometry. And the answer will be yes, because again, pressure depends on specific weight of the substance times the height. Okay, it does not depend on the weight or how the quantity. Therefore, the pressures in the cone at the bottom of the cylinder of the cone is the same as the pressure at the bottom of the cylinder. And the total weight of the fluid is not a controlling factor, recalling Pascal's law. Okay, that's it for this class. See you in the next one.